Okay, so we have read earlier on the basis of fundamental theorem of calculus. What was the fundamental theorem of calculus?
सर वो एरिया हेल्प करना
Yes, integral of a to b fx dx. This is the definite integral of fx from a to b and this definite integral is nothing but the area under the curve y is equals to fx and x-axis bounded by the lines x is equals to a and x is equals to b. Suppose this is the curve and these are the two vertical lines, x is equals to a and x is equals to b. So this area is nothing but this definite integral of the function from x is equals to a till x is equals to b. Right, so we can use this in finding out the areas of various curves. Suppose there is a circle whose radius is a, right? Now let's say we are interested in finding out the area of one quadrant. Area of one quarter circle. We know that the formula for the area of a complete circle is pi r square and divided by 4. So this should be the area. Now let's try to check it using this above theorem. We say the area will be area of this function, whatever this function is, y is equals to fx, from 0 to
A.
What will be this line? A. This is 0, x is equals to 0 is the y-axis and x is equal to a is this axis.
Yes.
This line. So अगर हम इसका एरिया to a fx dx निकाल लें, हमें वही आंसर मिलेगा जो हमें ज्योमेट्री ने दिया है, pi a square by 4. But before that, we need to know what this function is. And we know the equation of the circle centered at origin of radius a is equals to x square plus y square is equals to a square.
Yes.
So from here, what will be y?
Sir, root a square minus x square.
X square. So let's do that. 0 to a root a square minus x square dx. And this is a standard integral that we have learned in the indefinite integral course. इसका क्या फॉर्मूला होता है? इसका एक लंबा सा फॉर्मूला होता है, दो टर्म्स आती हैं. One of them is a square by 2 sin inverse x upon a, and what is the other one? X by 2 root a square minus x square. Integral is from 0 to a.
Yes, sir.
Know the definite integral, we just now need to put the values.
Yes, sir.
What will be that? We put a, what will we get?
Sir, we'll get 0 plus a square upon 2 sine inverse 1.
Very a square upon 2.
Sine inverse 1 is equal to pi by 2.
Sine inverse 1.
Pi by 2.
And 0 डालेंगे तो 0 plus 0.
Yes, sir. 0 plus 0.
And sine inverse 1, as you rightly said, sine inverse 1 is pi by 2. So a square by 2 into pi by 2.
Yes, sir.
Is equals to
Pi a square by 4.
a square by 4. Very simple application. Now we can also switch this, and we can also say that the integral of a to b of fy dy. This is also the area. But what will this area be? This area will be area between the
A
curve
to B.
x is equals to fy. Instead of y is equal to fx, now the function is the inverse function. X is equal to fy.
Yes,
And
sir.
the y-axis
Yes, sir.
between the horizontal lines y is equals to a and y is equals to b.
0.
Sorry, y is
B,
equal to
B. Oh,
yes, y is equal
oh
to
yes.
no, y is equal to b.
Yes, sir.
Because it is not 0, it is a and b.
Yes, sir.
So in that case, if the function goes like this, and these are the two horizontal lines, this is y is equals to a, y is equals to b. So this is the area that we are looking at.
Yes, sir.
We can also use this concept to find out the area bounded by two curves. Suppose this is one curve and this is another curve.
Yes, sir.
Let's say this is y is equals to f1x, and let's say this is y is equals to f2x. And let's say their point of intersection is x is equals to a. And this previous one is x is equals to 0. And we are interested in finding out this.
Yes, sir.
What we can do is f1 is more than f2. This area will be equal to integral from 0 to a
F1x F1x dx.
minus integral from 0 to a f2x dx.
Yes, sir.
f1x will give you this entire area, and f2x will give you this bottom white area, and we can subtract both of them. We'll get our answer.
सर आपने उल्टा f2x बड़ा एरिया नहीं देगा?
हाँ, 0 to a f2x minus f1x. So this should be f1 and this should be f2.
Yes.
You are absolutely right. So this is how we can calculate the area bounded by two curves. Now what will happen if, let's say, there are two curves like this, and there is another curve which is like this. Suppose this is x is equals to a, this is x is equals to b, and this is x is equals to 0. Now we are interested in finding out the area between these two curves. So this area and this area.
Yes, sir.
let's say this curve is 1 and this curve is 2. How do we find out this area? The area bounded by these two curves which are intersecting at 2 points now.
सर हम इंटीग्रल अलग अलग ले लें 0 to and a to b.
That is true. We can even do that. So what will be the area that you are saying? 0 to a
f2x minus f1x.
Yes, that is correct. f2x minus f1x plus which area?
सर वैसे मैंने गलत नहीं बोला शायद f1x ऊपर नहीं आएगा उसमें.
हाँ f1 ही आएगा. You are absolutely right, क्योंकि 1 बड़ा है f2 से उस केस में तो.
Yes sir. सर plus f2x minus plus integral of a to b f2x minus f1x.
f2x minus f1x. Now instead of that, if I do area is equals to integral of 0 to b mod of f1x minus f2x.
Yes sir.
Can this work? The point is this. हम पूरा का पूरा इंटीग्रेट कर दें और हम भूल ही जाएं कि कौन सा फंक्शन बड़ा है कहां पे.
Yes sir.
This formula works if, let's say, the curve were like that. This is easy to understand. चाहे f1 बड़ा हो चाहे f2 बड़ा हो, अगर हमने मॉड ले लिया डिफरेंस का और इंटीग्रेट करा तो हमें आंसर मिल जाएगा. लेट्स से दिस इज 0, दिस इज b.
Yes sir.
राइट, क्योंकि एरिया तो पॉजिटिव माना जाता है. मॉड ले लो, नेगेटिव आएगा तो पॉजिटिव बन जाएगा, और पॉजिटिव आएगा तो हमने ठीक ही लिया होगा. f1 इसको लिया होगा, f2 इसको लिया होगा. Right?
Yes sir.
So if I now try to break this into two parts for the second situation, and let's see what happens. 0 to b को हम break कर सकते हैं 0 to a and from a to b.
Yes sir.
Mod of f1x minus minus f2x plus same thing mod of f1x minus f2x mod.
Yes sir.
And now we realize that from 0 to a, 1x minus f2x will be positive.
Yes sir.
So we can remove the mod. f1x minus f2x. And we realize from a to b, in order to make this difference positive, we should ideally do f2 minus f.
Yes sir.
f2x minus f1x. Right?
Yes sir.
That means this will always give us the right integral, right area. Right? This is very helpful in situations where the graph is like this. Suppose this is y is equals to cos x. And we know that this point is pi by 2. And this is pi. So if I need to find the area from 0 to pi of cos x dx, If you don't apply the mod, see what happens. What will be the area of 0 to pi cos x dx?
So sin x sin pi by 1.
Minus cos x का integral is
Sir, sin x.
sin x from 0 to pi.
Yes, 0
And
to
what
pi.
is sin pi?
Sir, -1.
No. Sine is always 0 at integral multiple
Oh,
pi.
yes, sir. Yes, sir. Yes, sir.
So this is coming out to be 0. Integral of 0
Yes,
to
sir.
pi.
Yes, sir.
और वो आना भी चाहिए because ये एक odd function है. इधर पॉजिटिव है, इधर नेगेटिव है.
Yes, sir.
राइट? वो 0 to 2 है fx dx वाली प्रॉपर्टी से. राइट?
Yes, sir.
इसलिए अगर कोई फंक्शन x एक्सिस के ऊपर नीचे है और उसका आपको एरिया ढूंढना है तो या तो आप पहले मॉड लो उसका, या फिर दो अलग अलग पार्ट में डिस्ट्रीब्यूट करो.
Yes, sir.
बिकॉज दोनों एरिया कट रहे हैं यहाँ पे. दिस एरिया एंड दिस एरिया आर कैंसलिंग आउट आइडियली. Right? So ideal way is break it down into two parts. 0 to pi by 2 cos x dx plus pi by 2 to pi. सेकेंड क्वाड्रेंट में cos नेगेटिव होता है तो इसलिए पॉजिटिव बनाने के लिए माइनस cos x dx.
Yes, sir.
This will give you the right area. तो 0 to pi by 2 cos x हो जाएगा sin x from 0 to pi by 2 और minus again sin x from pi by 2 to pi. Sin 91 sin 0 0 minus sin pi 0 sin 91, which is equals to 1 plus 1, which is equals to 2 units.
Yes, sir.
Right? So this area and this area is actually 1 square unit total. And 1 plus 1 becomes 2. Otherwise 1 and 1 was cancelling out because this is theoretically positive 1 and this is
Yes.
negative 1.
Negative.
तो मॉडुलस ले लेना है, हमें एरिया ढूंढना है.
Yes, sir.
ठीक है. So I think this is pretty much it about the application. Now we can start doing the questions.